this video, we will sketch the graphs and identify the properties of graphs of inverse trigonometric functions. Recall that by inspecting the graph of a function, we will be able to know if its inverse exists or not. If it passes the horizontal line test, that is, if we let a horizontal line pass through the graph at any point, it should only intersect the graph once. Then the graph has an inverse. With that definition then, 3 among these 4 graphs here, including the graph of f of x is equal to sine x, doesn't have an inverse. Well, the good news is we can actually restrict the domain of sine x so we can obtain its inverse. Restricting the domain is like saying we cut the graph to a domain where it passes the horizontal line test. We choose the restricted domain from one period and it should include the number 0. We choose a convenient interval to restrict the domain from negative pi over 2 to pi over 2. It includes 0 and it makes the graph pass the horizontal line test. Before proceeding further to identifying the properties of graphs of inverse trigonometric functions, let's also recall that another property of graphs of inverse functions is that the graph of the function and the graph of its inverse are symmetric about the line y equals x. Both are graphed here in different colors, and as you see, they are indeed symmetric along the line f of x is equal to x. Let us now discuss the properties of the inverse sine function. Let us have a closer look at the graph of f of x equals sine inverse of x. By carefully examining the graph, we will be able to identify the following properties. Its domain is from negative 1 to 1 inclusive, and its range is from negative pi over 2 to pi over 2 inclusive. Looking at where it intersects both the x-axis and the y-axis, we know that the x-intercept is 0 and the y-intercept is also 0. We see that the graph is increasing and has no holes, gaps, nor breaks in it. Thus, it is continuous. It is also an odd function. Thus, it is symmetric along the origin. Let us also examine the inverse cosine function. Similar to what we did to the sine function, we also have to restrict the domain of the cosine function so we can obtain its inverse. The graph in the restricted domain 0 to pi inclusive is in blue. Now that we have restricted the domain of cosine x, we can obtain cosine inverse of x. Its graph is shown in red. As you see, they are also symmetric along the line y equals x. Let us have a closer look at the graph of f of x is equal to cosine inverse of x. By carefully examining the graph, we will be able to identify the following properties. Its domain is from negative 1 to 1 inclusive, and its range is from 0 to pi inclusive. Looking at where it intersects the x-axis, we know that the x-intercept is 1. Meanwhile, examining at where it intersects the y-axis, we know that the y-intercept is pi over 2. Unlike the graph of the inverse sine function, the graph of the inverse cosine function is decreasing. It is a continuous function, and it is neither odd nor even. That means that it is neither symmetric with respect to the origin nor the y-axis. Lastly, let's have the inverse tangent function. Following the same logic that we had for the first two trigonometric functions, we will also restrict the domain of the tangent function so we can have its inverse. The graph in the restricted domain negative pi over 2 to pi over 2 is shown in red. Since we have restricted the domain of tangent of x, we may now obtain the tangent inverse of x. Its graph is shown in red. As you see, they are symmetric along the line y equals x. Let us also have a closer look at the graph of f of x is equal to the tangent inverse of x. If we carefully examine the graph, we will be able to identify the following properties. First, its domain is from negative infinity to positive infinity, and its range is from negative pi over 2 to pi over 2 exclusive. Looking at the point of intersection between the graph and the axes, we see that the x-intercept is 0 and the y-intercept is 0. It is an increasing and continuous function, and it is also symmetric to the origin because it is an odd function. Recall that the tangent function has vertical asymptotes. This time, the graph of the inverse tangent function has horizontal asymptotes at y equals negative pi over 2 and y is equal to pi over 2. To have some practice in recalling these concepts, please quiz yourself with the code 209-85020 on quizzes.com. This quiz will expire on March 6, 2021, so please be sure to play it before it expires. We again thank the developers of the GeoGebra app which I use in drawing the illustrations in this video.